Hello, this is Elizabeth Pluswick, and today's video is going to demonstrate gradients. Gradients, designated by the letter G, is a series of cash flows similar to an annuity and a series of cash flows that happen at regular intervals, but they increase in amount every year or decrease in amount with every payment. The rules of a gradient are that it must start at zero and have equal increases each year or each period. The cash flows in the gradient can be coming into the company, designated by up arrows, or a gradient could be comprised of cash flows that are going out of the company. The main thing is that they start at zero, and this first payment must be the same amount as the increases subsequent to that. That's a timeline of a picture of a gradient. Now, sometimes that's not actually the case. If you have a situation where the actual cash flows do not start at zero, but that they start at some amount and then have uniform increases after that, you can take that series of cash flows, again, whether in or out, you can take that series of cash flows and turn it into an annuity. If you draw a line straight across there, every single cash flow has this amount of cash, so that's the amount of the annuity, plus then a gradient that starts at zero, follows the rules of gradients, starts at zero, and has a uniform increase in each subsequent cash flow. So we can take the annuity portion of the cash flows plus then the gradient portion that starts at zero and has equal uniform increases. And again, the amount of the G is the amount of the increase. So if this increase was $35 and this one was $70 total, another $35 added onto it for a total of $70, then the amount of the G would be $35. All right, let's look at an example in the back of your handout, problem 27. Looks like this. The maintenance expense on a piece of machinery is $150 in year one, going up to $300 in year two for maintenance cost, $450, $600. I see a pattern there. Each year's maintenance cost is increasing by $150. I see a problem that the first payment doesn't start at zero, it starts at a dollar amount. So we're going to have to take these cash flows and turn it into we're going to have to treat this first year a little bit differently because we need the gradient to start at zero and then go on for a period of time. Let's continue with the problem. If the interest rate for this problem, for this situation, is 8%, that's the discount rate or the interest rate, the equivalent uniform annual maintenance cost, EUAC, is closest to, and then some dollar amount of choices. So what we've got here is we're asked to find the equal uniform annual cost, which is an annuity, an average annual cost for running maintenance on that machine. Even though it increases in amount every year, we want to say, what's the average cost of maintenance over the 4 years? So we're asked to find A. Given, what are we given? We're given an interest rate of 8% per year. Everything is in terms of years in this case, so we don't need to do any translation to the interest rate. The N, number of years, is 4. So the interest rate is on an annual basis and the time period is on an annual basis. So we don't need to do any adjustment of either of those. Let's draw a little timeline now to show the cash flows in this problem. I've written down arrows because the cash is going out, its maintenance cost. 150, 300, 450, and 600 for years 1 through 4. We're asked to turn this series of future cash flows into an average amount per year or equal uniform annual cost, which we know is A, an annuity. So what we've got to do here is start with treating the first year differently because it's not really quite a gradient. It starts at 150. The amount of the gradient, the amount of change between each of these years, the amount of the G is 150. And we need it to start at zero. To be a gradient has to start at zero. So we're going to treat this first year as its own separate cash flow of $150, then with an increase of $150 G in every subsequent year. So how we write that is the amount of the annuity, what we're asked to find, is 1 year's cash flow at $150, plus then a gradient of $150, the increase each subsequent year. We're asked to find A given G, interest rate of 8% for 4 years. $150 plus 150 times the factor from this area of the 8% interest tables. We go to the find A given G column, down to n equals 4, and here's the factor. So multiplying all that out and then adding the first year's cash flow, the answer is $361. The closest answer choice is answer choice C, and that is at the annuity, the equal uniform average cost of running that equipment and paying the maintenance costs over the 4 years. It averages out at a discount rate of 8% to be about $361 average per year. And that's one way to handle a gradient problem.